Hey, hi, Rajan this side. So today we are going to discuss the problem asked in LeetCode Weekly Contest 422. I'll be discussing the first three problems. So let's start with the first problem. So the first problem is basically you have to check whether the given string is balanced or not. So the string is given that consists of many digits and you have to check whether it is balanced or not. And the definition of balance is that if the sum of digit at the even place is equal to sum of digit at the odd place, then the string is called balanced, otherwise unbalanced. So I'll just quickly go through the code. So this is the code. This is your given string, and so I have taken two variables here, even sum and odd sum. Even sum is basically store the sum of digits at the even places, and odd sum is store the sum of digits at the odd places. So just iterate through this loop, and if your index is even, then like add that digit to the even sum. If the index is odd, add that digit to the odd sum, and at the end just check like whether both are equal or not. So if both are equal, it will be balanced, otherwise it won't be balanced. Yeah, so now let's move to the second problem. So this is the second problem asked in the contest, and the problem description says that you are given a two-dimensional matrix called move time of size n cross m, where move time ij represents the minimum time in second you can start moving into that room. And you are starting your journey from 0 comma 0, and at time t is equal to 0, and for each move you can move to any of the adjacent rooms, right? And moving between adjacent room exactly takes 1 second, and at the end you have to find what is the minimum time to reach at the uh, bottom right cell, which is n minus 1 comma m minus 1. And two room are called adjacent if they share a common wall, like either horizontally or vertically. So the first sample test case is 0444. So before explaining the sample test case, I will explain one most important point about this problem. So let's say this is your current cell and this is your adjacent cell, right? Let's say this is the time when you reach here, t1, and this is your move time, this is your t2, which is actually your move time, right? So there are two cases. The first case is if your t1 is less than t2, it means that you reach at this point which is less than your move time of this next adjacent cell. In that situation, you have to wait here until you cross the t2 time, and once you cross the t2 time, just make one extra move to reach here. So in this case, the time when you reach at t2 would be t2 plus 1. And the second case is when your t1 is greater than or equals to t2. If the time when you reach at your current cell is at least t2, it means that you don't have to wait like any extra seconds. Just make an extra move to the to move to the adjacent cell. In this situation, your time would be t1 plus 1. Or in other words, in one line I can say it 1 plus 1 plus max of t1 comma t2. So this is the time when you will reach to the adjacent cell. This is the most important part here. Now let's quickly start with the test case. So this is so you are starting your journey at the 0 comma 0 at time t is equal to 0, right? So let's see when you will reach here. So you are at cell t is at cell 0 comma 0 at time t is equal to 0, and the move time of the right cell says that you have to start your journey at time t is equal to 4. So this is your case number 1, when your t1 is less than t2, where t2 is your move time. So in that situation, your answer will be t2 plus 1. So you will reach here at time t is equal to 5. 5 means you are starting your journey at time t is equal to 4 and 1 extra second for for one movement, and same applies here as well. 5 here. Now when you start moving from this cell to this cell, this lies in the second test case, like the second case, when your t1 is greater than or equal to t2. In that situation your answer would be t1 plus 1, which is 5 plus 1, which is 6, or you can just check 1 plus max of t1 comma t2. Same applying here as well, so your answer is 6. Right, this is, but if you are going to implement this in a brute force way, then the complexity would be exponential, which is, so for each cell there are 4 ways, right? Up, down, left and right. So total 4 ways. So let's say there are n how many cells are possible? There are n into m number of cells are possible. So the time complexity would approximately would be 4 to the power n, 4 to the power n into m, right? Now let's see how we can quickly reduce the complexity from exponential to polynomial. So we have given a graph of size n cross m where each cell is connected to any of the 4 adjacent cell. Means we can move from one cell to any of the 4 adjacent cell. So just think about it as a graph problem where you have certain number of vertices and certain number of edges which are connected between them, and you have to find the minimum time to reach from source to destination. We know that this is a single source shortest path problem which can easily be solved using one of the famous algorithm called Dijkstra, right? Dijkstra algorithm. And like let's say you are having v number of vertices and e number of edges, then the complexity of Dijkstra algorithm is order of e plus v log v, or in a simple term I can say it order of n log n. So just apply this Dijkstra algorithm to this matrix, and you can and use the concept which I already explained here to make the decision. If your current time at which you the time at which you are at current cell is t1, and if you want to make the move to the next adjacent cell of which has the move time of t2, then the time to reach at t2 would be 1 plus max of t1 comma t2. So now let's see how we can write a code for it. This is the code of the second problem. So let's see how the implementation goes. So we know that like in a Dijkstra algorithm we need a priority queue to store the cost at each cell and what is the coordinate of that cell. So here instead of cost we have time. So your priority queue store two things. The first thing is what is the time when you reach the current cell and what is the cell coordinate. And I have stored the cost in a dp array. So dp of 0 0 is equal to 0. It means that you are starting your journey at the origin, which is 0 comma 0, and the initial time is 0. I just inserted that value in that priority queue, 0, and the time when you reach at cell, which is 0, because you are starting your journey from there itself, and this coordinate. Now I'm going through this while loop. So this is the standard implementation of Dijkstra algorithm. I just took the minimum time to reach any cell. So this is your current time. So this is your current time, and this is your position. This position is actually your cell coordinate. So I remove it from here, and then I'm going through each of the 4 possible adjacent, right? So there are 4: up, down, left and right. So I have found those adjacent cell. Then I calculated what is the time when you will reach to that cell. So we know that the new time would be 1 plus maximum of your current time comma your move time, which I have already explained in my explanation part. You can watch it again. So this is the time when you reach to the adjacent cell, and then I just checked whether the already stored time is more than the current time. If it is more than the new time when you will reach it, just update it and then insert it in the priority queue, and then at the end of this code just return the cost to reach the minimum time to reach at the bottom right cell, which is n minus 1 n minus 1. This is the third problem asked in the weekly contest 422. This problem is the extension of the previous problem, right, where everything is exactly same, just one difference that when you want to make the adjacent moves, then so like in the problem 2, it was the time to reach from one shell to adjacent was just 1 second, but here the time to move from one cell to adjacent would be 1, then 2, then alternate of 1 2 1 2 1 2. Right. So what I mean is that, let's say these are 3 cells. I move from here to here, then it would take 1 second. If I move from the second cell to the third cell, the time taken would be 2. And again, if you are like moving from third cell to any fourth cell, the time again would be 1. So it would be alternate of 1 2 1. So like you can, so the concept is still the same. You are going to use the same concept which you used in the second problem, just one difference. So here if you look at it, I just took 1 plus max of t1 comma t2, because in the second problem it says that the cost from reach from any cell to adjacent would be 1 second, but here the cost is alternate of 1 to 1 2, so you have to take care of this case as well. Otherwise rest everything is same. Your Dijkstra concept, your this concept which I explained, everything is going to be the same. So let's quickly look at the code of the third problem then. This is the code of third problem. See, the only difference is in the priority queue, right? Earlier I was just storing what is the time to reach at that cell and what is the coordinate, but here we need one more information to store what is your move value. So your move value would either be 1 or 2. So here I started it from cell 0 comma 0. Again the cost is 0, this is your coordinate, and this one actually says that this is what is the move cost it would take, like what is the cost it would take to move from this current shell to adjacent cell. So since you are starting from origin which is 0 comma 0 and this is your first move, your cost is going to be just 1. And again I did the same thing again. So here this is your c time, this is your position, so this is your I and j, this is your cell, and this is your what is your previous cost to move from previous cell to the current cell, right? Again now, like, so we know that if your previous cost was 2, your current cost is going to be 1, and if your previous cost was 1, your current cost is going to be 2. So I just found it here, what is the additional cost you are going to keep it. So if your previous one, it the current cost is going to be 2. If your previous was 2, it is going to be 1. Again the same code, but here like earlier it was just 1 plus max of this, but here it would be previous, because now we have to take care that whether the previous cost was like what was the previous cost, because it like it could be either 1 or 2. Again I just kept, like found what is the time at which you will reach from current shell to adjacent shell, and same if your dp value is more than your current time, it means that this is your optimized time. So optimal time, just update it your dp and insert it to the priority queue, and at the end return your dp of n minus 1 n minus 1. So this is the implementation of third problem. If you find this video helpful, please like and subscribe to my channel, and stay tuned for more such videos. Thanks for watching.